The next 10 years will probably change the world more than the last 5 decades combined. That is not a dramatic exaggeration. That is what is actually happening right now inside labs, factories, and research centers across the planet. Technologies that sounded like science fiction only a few years ago are quietly leaving the laboratory and stepping into real life, into hospitals, into factories, into cars, and into homes. What you are about to hear is not a countdown of gadgets. It is a look at the 10 forces most likely to reshape work, health, transportation, energy, and daily life in the United States before the next decade ends. Some of these are already here, working quietly in the background. Others are still experimental, still fragile, still years away from your driveway or your doctor's office. But together, they point toward the same conclusion. The future is arriving faster than most people realize. Let's start at number 10, space infrastructure and the new economy above our heads. For most of history, space was something governments controlled entirely. Slow, expensive, and closed off to private companies. That has changed. Reusable rockets, large satellite networks, and early experiments in manufacturing things in orbit are turning space into an actual business, not just a government project. Companies like SpaceX and Blue Origin, along with a growing list of satellite firms working alongside NASA and other space agencies, are already running profitable operations in orbit today. Internet service beamed down from thousands of small satellites is already a real product people use. What is still experimental is manufacturing physical goods in orbit and building sustainable lunar infrastructure, both of which remain economically uncertain. The obstacle here is simple economics. Until building things in space becomes cheaper than building them on Earth, this stays a specialized industry rather than something that touches everyday American life directly. But it matters because it is quietly rewriting how global communication and observation work, and that affects everything from weather forecasting to farming. But that is nothing compared to what comes next. At number 9, we have artificial intelligence accelerating scientific discovery itself. Imagine shrinking years of laboratory research into a matter of months. That is the promise behind combining generative AI models with automated robotic labs that can run thousands of experiments without a human touching a single test tube. Companies like DeepMind, along with major pharmaceutical firms and university research centers, are already using these systems to design new drugs, new materials, and new chemical compounds far faster than traditional trial and error ever allowed. This is already happening in real laboratories today. It is not speculation. What remains uncertain is how quickly these digital discoveries can be validated in the physical world, since a chemical that looks perfect in a simulation still has to survive real-world testing. If this technology can shrink drug development from a decade down to a couple of years, it will not just save lives, it will save the entire economy from the enormous cost of modern medical research. If artificial intelligence can accelerate an entire industry's research, imagine what happens when it starts replacing entire supply chains for global energy. That brings us to number 8, green hydrogen and the electrification of heavy industry. Some things are very hard to run on batteries alone. Giant cargo ships, steel furnaces, and airplanes need enormous amounts of concentrated energy that current battery technology simply cannot deliver efficiently. Green hydrogen made using clean electricity instead of fossil fuels is one of the leading solutions being tested by companies like Siemens and ABB, along with oil and gas giants like Shell and BP, who are now pivoting part of their business toward it. Pilot plants are already running today, but full commercial scale adoption depends heavily on cost, and right now green hydrogen is still more expensive than the fossil fuel alternatives it is meant to replace. If costs come down as expected through the early 2030s, entire industries that seemed impossible to decarbonize, like steel production and international shipping, could finally clean up their act. Now picture something even stranger. Computers that do not just work faster, they work in an entirely different way from anything you have ever used. That is number 7, quantum technology. A traditional computer solves problems one step at a time, but a quantum computer can explore many possibilities simultaneously, which makes it extraordinarily good at specific types of problems, like simulating molecules or optimizing massive logistics networks. Companies like IBM, Google, and IonQ, alongside national research labs, have already built early working quantum systems. This part is a verified, documented fact. What is still uncertain, and this is important, is when quantum computers will become genuinely useful for everyday industrial problems, because the technology still struggles badly with errors and instability. Most experts agree meaningful, widespread quantum advantage for real business use is unlikely before the next decade even begins. This one is a slow burn, but when it eventually works at scale, it could transform drug discovery, material science, and even how we secure digital communication. If quantum computing rewires how we calculate the world, robotics is about to rewire who actually does the physical work in it. That is number 6, advanced robotics stepping outside the factory floor. For years, robots have been locked away in structured environments like car assembly lines, doing the same repetitive motion over and over. That is changing fast. Companies like Boston Dynamics, Figure, and Unitree, along with major industrial names like Amazon and ABB, are now building robots that can walk, balance, grip, and adapt to unpredictable environments like warehouses and eventually homes. Warehouse and factory robotics are already commercially deployed across the United States right now. Robots working in unpredictable environments like your living room or a construction site are still in early pilot stages. The biggest obstacle is not building the robot body, it is teaching the robot brain to handle situations it has never seen before, safely and reliably. If this problem gets solved, and many experts think it will within the next decade, it could reshape everything from elderly care to home construction. Now here is where things start getting personal. Technology that connects directly to the human brain. Number 5 is brain-computer interfaces. Devices that read electrical signals from your brain and translate them into action. For people who have lost the ability to move or speak due to injury or disease, this is not science fiction. It is already changing lives in early clinical trials right now. Companies like Neuralink and Synchron, working alongside major medical research hospitals, have successfully allowed some patients to control computers or communicate using only their thoughts. This is a documented, verified medical result. What remains speculative is the idea of healthy people using brain implants for everyday convenience. That possibility is still many years away and depends heavily on solving serious safety and privacy concerns first. The near-term impact here is deeply human, restoring communication and independence to people who lost it, and that alone makes this one of the most emotionally powerful technologies on this entire list. As incredible as reading the brain is, rewriting the biology of life itself might be even bigger. That is number 4, precision biology and genetic engineering. This is the science of editing genes with extreme precision, and it is already saving lives today through mRNA vaccines and new gene therapies developed by companies like Moderna and BioNTech, along with gene editing pioneers like Intellia and Editas. Beyond medicine, this same technology is being used to engineer crops that resist drought and disease, and to create lab-grown materials that could replace resource-heavy industrial manufacturing. Medical applications are already real and approved for use. That is verified fact. Widespread industrial biotechnology, like replacing plastic manufacturing with engineered organisms, is still in earlier commercial stages. The biggest obstacle is not the science itself, it is regulation and public trust, since editing biology raises serious ethical questions that societies are still working through. If this technology matures as expected, it could transform how we grow food, treat disease, and manufacture everyday materials all at once. Now let's talk about the ground beneath your feet, or more specifically, the power running through it. Number 3 is the complete overhaul of how America generates and stores electricity. Solar and wind power are already the cheapest form of new electricity in most of the country today. That part is not speculation, it is documented economic fact. The real challenge has always been storage. What happens when the sun is not shining or the wind is not blowing? Companies like Tesla's energy division, along with Siemens, ABB, and utility companies working with government programs, are now racing to build long-duration storage systems and smarter, more flexible power grids. Solar and wind generation is fully commercial and scaling today. Long-duration storage and modernized grid infrastructure are still being built out. The obstacle is not technology, it is construction, permitting, and the sheer scale of physically rebuilding an electric grid that took a century to construct in the first place. Get this right, and cheap, clean, reliable power becomes the invisible foundation underneath every other technology on this list. If you thought the power grid transformation was big, think about what happens when it meets the vehicle sitting in your driveway. Number 2 is the battery revolution reshaping transportation. Electric vehicles have already moved from niche curiosity to mainstream product, and that shift was made possible by massive improvements in battery chemistry from companies like CATL, BYD, Tesla, and Panasonic, alongside nearly every major automaker on Earth. Current generation lithium batteries are already commercial and improving every year. That part is fact. Solid-state batteries, which promise even faster charging and longer range, are still in pilot and early demonstration vehicles, not yet available to the average buyer. The biggest bottleneck is not chemistry, it is raw materials, since nickel, lithium, and cobalt supply chains are being stretched globally by demand. Here's a question worth sitting with for a second. When battery costs finally drop enough to make electric vehicles cheaper than gas cars to buy outright, not just to own, what happens to the entire American auto industry as we know it? And now the technology sitting at number one, the one experts across nearly every field agree will reshape more of daily life than anything else on this list: artificial intelligence itself, especially the kind that can plan, reason, and take action on its own. This is not simple chatbot technology anymore. Companies like OpenAI, Google DeepMind, Microsoft, Anthropic, and NVIDIA are building systems capable of writing software, assisting scientific research, running business operations, and increasingly taking multi-step actions with very little human guidance. This is already being deployed inside real companies today. That part is documented fact, according to research from firms like McKinsey showing rapid enterprise adoption already underway. What remains uncertain, and this is genuinely debated by experts, is how quickly this technology reshapes entire job categories, and whether safety and regulation can keep pace with how fast the technology itself is improving. The reason this sits at number one is not because it is flashy, it is because it touches every single other technology on this list, speeding up biology research, optimizing power grids, designing better batteries, and even helping robots learn faster. To make sure you are not caught off guard by what is coming next for the industry, join us here because this story is only getting started.